Namaste everyone. Welcome to optics class. Today we are just shifting it to next chapter related to optics only, light only. We have studied ray optics, in which we take the rectilinear property of light. Light always travels in straight line. That property is considered, and the phenomenon of light like reflection, refraction, everything is studied. Reflection in plane surface, curved surface, refraction in plane curved surfaces, everything we have seen it in detail, and we have worked out problems. Now we will come to wave optics. What is wave optics? It is the nature of light. What is light? What does it consist of, and how does it travel? Why medium is not necessary for the traveling of light? All these things are studied in wave nature. That is a wave property or wave optics. Now, so many people have tried their level best in the olden days. Many scientists have tried their level best to understand light. Light is a very fascinating thing, and it has no mass. It travels with very tremendous high speed, and all those things. So, what is it made up of? How does it, without any mass, how can it travel from one place to another? How can it carry energy? So all these things were in history we have in records saying that Descartes, he is the first scientist who said that light is made up of particles, and he had his own theory, but he didn't put all these his ideas in a proper way. So he had given some ideas saying that light is made up of particles, and they travel with tremendous high speed, and so and so. And Newton took all these ideas and put it in a proper way, and he gave a theory called Corpuscular Theory of light. So we always attach the name of Newton for corpuscular theory, even though many ideas were from Descartes. So corpuscular theory of light. So according to corpuscular theory of light, so many ideas are from Descartes. According to this theory, light is made up of small particles, and these particles travel with the very high speed. And whenever a particle travels with very high speed, usually you know that it moves in a straight line. So that is why the light travels in straight line. And different colors are because of different sized particles. That's what they say. Of course, all these are just assumptions, and there was no mathematical proof, there was no practical proof behind it. So these corpuscles travel with very high speed, and different size of the corpuscles gave different colors to light. And you know that Newton was the first person to pass the light through a prism and show that it contains different colors. So why light appears in different colors? The reason is of different corpuscles. That's what he said. So these particles, whatever they are called as corpuscles, when they hit the surface, some surfaces attract corpuscles, some surfaces repel corpuscles. That is why we get reflection and refraction. Newton said, suppose these corpuscles of particular size, that means light of particular color I am saying. So when these corpuscles fall on the surface of water, say this is water from air, then he says that all these corpuscles are attracted normally towards the surface. So those corpuscles, instead of traveling in the same direction, they started traveling in some other direction, because they got the one attractive force as soon as they touch the surface. So according to corpuscular theory, a refracting surface attracts these corpuscles, and again when it falls on a reflecting surface, there is a force of repulsion. So when the corpuscles fall on a reflecting surface, there is a normal force of repulsion. That is why corpuscles are reflected like this. That is his own theory. And the main drawback, we don't use corpuscular theory nowadays. What is the problem? The main drawback of the corpuscular theory is it says that light bends away when it travels from rarer to denser medium, which is against the practical results. We know that when a ray of light travels from rarer to denser medium, for example air to glass, you know that it bends towards the normal. Suppose this is the normal, and if this is the incident ray, if this is the original direction, it bends towards the normal. But according to corpuscular theory, it bends away from the normal. What does it mean? Its speed increases. So when a ray of light travels from rarer to denser medium, the speed of light increases. That is what is the result of explanations given in corpuscular theory. So that was against the practical results, and practically it was shown that light, as it travels from rarer to denser medium, its speed decreases, that's why it bends towards the normal, and that was a major blow to corpuscular theory, and people started rejecting it because it was not able to say the experiment, it was not able to explain the experimental facts which say that light travels, as it travels from rarer to denser medium, its speed should decrease and it should bend towards the normal. But corpuscular theory said that it bends away from the normal and its speed increases. In denser medium, definitely velocity of light should go on decreasing. So, and even that the corpuscular theory had a small problem. Simultaneous reflection and refraction was not explained. When light falls on the surface of water, you know that a part of it gets reflected, a part of that light gets refracted. So what does that medium do then? Whether it attracts the corpuscles or reflects the corpuscles or repels the corpuscles. Because according to Newton, when corpuscles fall on a reflecting surface, there is a normal force of repulsion. So they move like this. For a refracting surface, there is an attraction. So they move in a different direction. But what about simultaneous reflection and refraction? That was not explained. Why does a medium attract some corpuscles and repel some corpuscles? That was the confusion. So again, that is a drawback, and the main drawback is light, as it travels from rarer to denser medium, it moves with more speed and bends away from the normal. That was according to corpuscular theory, so it went wrong, and then a new theory was proposed, and that was from Christian Huygens. Huygens wave theory. He said that light is a wave. Of course, this theory also had some drawbacks, but this theory was a successful theory in many aspects. It was able to explain many phenomena related to light, like reflection, refraction, interference, and even then it was able to prove, using this theory, now we are able to prove Snell's law and everything. So wave theory, according to Christian Huygens, light is a wave. It's a wave, but by then there was no idea of non-mechanical wave. Nowadays we know that there are two types of waves, mechanical and non-mechanical. Mechanical waves require a medium, for example sound, water ripples. Without water, how can you assume water ripples? They need a medium, sound needs a medium, in vacuum sound can't travel. So that was the idea of the people at that time. But nowadays we know that there is one more type of wave called light, electromagnetic wave, whatever we call, and it does not require any medium. It may travel even in water as well as vacuum. So light from the sun reaches the earth, and major portion of the traveling is in vacuum. So light travels in vacuum. Now, Huygens said that light is a wave, and when that wave travels, it produces secondary waves, and his theory goes on like this. Now the first question is, how could light travel in vacuum? Because people were having an idea that for any wave, medium is a very necessary factor. But without medium, light can travel. But that was a practically observed fact, because from the sun we receive light, and major portion of the gap is vacuum. So light travels in vacuum. If Huygens says that light is a wave, how could light travel in vacuum? And that part of the question was not satisfactorily explained by Huygens. We will say what he says in later stage. Of course, Huygens says finally that there is a medium, there is ether everywhere, and using that hypothetical medium, that is just an assumption that there is a ether medium everywhere. Using ether medium, light travels. That's what he says. But ether was disproved, and that was a ether. Ether means everywhere present. That is what the meaning. So that the presence of ether everywhere was disproved, and his idea, that Christian Huygens' idea of assumption of ether was very beautiful. Like this, suppose you have a tank and put some plastic balls in that, those plastic balls will be floating in the water tank. Then water is the medium in which it is floating. Similarly, all these planets are floating in the universe, and in the whole universe there is ether. In the ether, all these planets are floating as if plastic balls are floating in water. That was his assumption. And using this ether medium, light can travel. That is what he said. So if you can assume ether everywhere, there is no question of how does light travel in vacuum. So that was a theory given by Huygens. Only in this part he fails. to explain how does light travel in vacuum, because there is no practical proof for ether. But later on, many experiments, important and historic experiments, proved that there is no ether. So that was a major blow, but still even today we use wave theory. We treat light sometimes as wave, sometimes as packets of energy called quanta, you know that, and it is an electromagnetic wave, and all these developments occurred later stage by stage. But now we will have to go for wave optics, and that is wave nature of light. So Huygens said that light is a wave. And initially he said that it is a longitudinal wave. You know what is a longitudinal wave? Sound is a longitudinal wave. As I talk, the air molecules are disturbed and the air molecules start vibrating like this. And as the air molecules in this region start vibrating, the molecules on the other side are disturbed. As if you are standing in a queue. If one person falls, then all are disturbed. So one molecule is disturbed, the other molecule is also disturbed. So the disturbance moves. Disturbance moves and the particles vibrate in the same direction. The vibration direction and the propagation of the wave are in parallel to each other. Then such a wave is called longitudinal wave. He said that light is a longitudinal wave in particular. But later on he corrects his theory, saying that light is a transverse wave, because light started showing a property called polarization. You will come to know about this in this chapter only at the end. So there is one more property called polarization. As if light can show photoelectric effect, light can show reflection, light can show refraction, it can show polarization also. And one thing was very clear by that time, that if any wave shows polarization, then it is only by transverse waves. So if any media, any wave can show polarization, then that wave must be transverse. Huygens initially said that light is a longitudinal wave, but light started showing polarization. For the time being, you take it as a property. We will see what is polarization in detail. Then you will come to know that you can't assume a property like polarization for a longitudinal wave. Longitudinal wave has nothing to do with polarization. So only transverse waves can show polarization. What is a transverse wave? The wave in which particles vibrate perpendicular to the propagation. Water ripples, water molecules vibrate like this on the surface, and water ripple moves parallel to the surface. But vibration is perpendicular. So that is a transverse wave. Light is a transverse wave because it shows polarization. This is the particular property which proves that light is transverse in nature. And he corrected himself, saying that, oh yes, light is a transverse wave. But in the beginning he says that light is a longitudinal wave. And he says, how does light travel? And his theory is entirely a beautiful imagination. He says, suppose there is a source of light. From the source, waves will start. They grow. For example, if you switch on a bulb, if you have a bulb like this, small bulb, I'll say, filament bulb, switch it on. In what directions the light will travel? Light will travel in all the directions, three-dimensional, 360 degrees. Light will travel in this direction, like this, like this, like this. Now, you switch on the bulb, and simply we will imagine a case that bulb is a living object and it listens to us and it behaves as if we say, it follows our orders. Switch it on, emit the waves. Say the waves start emitting in all the directions. In the board, I can show only a two-dimensional picture, but you have to imagine it. Of course, I am going to show all these things in a PPT after I complete it in the classroom, because some PPT, some animations will give you the clear idea. Now I will try to explain as far as possible in the two-dimensional board. Now, what happens? Waves will come here, waves will come here. Now, let us assume that they are like water ripples. One crest, one trough, one crest, one trough. So, you will see the water ripples like this. In the same way, light travels, let us assume. Now, suppose one wave forms 4 crests and 4 troughs and stops here. We will say stop. Light stops emitting waves. Same 4 crests and 4 troughs will travel here. 4 crests and 4 troughs here. 4 crests and 4 troughs here. That means the last trough, say 4th trough is here. This will also produce the 4th trough. This will also produce the 4th trough. Of course, in this chapter you need a lot of imagination, because everything is based on that imagination, because you can't see it. You can see only light. You can't see all these types of theories, the concepts of theories behind it. You have to understand it, that's all. So understanding light in some or other manner, understanding your friend in some way. Your friend may not be so, right? But still we understand him to little extent. From 40 to 50% we can understand, but remaining 50% we can't understand. So we will explain that our friend is like this, like this, like this. Out of that explanation, only 40% or 50% may be true. Similarly, we don't know actually what light is. We'll try to understand it by saying that from the light source, waves will travel. And this ends in the fourth trough. This also ends in the fourth trough, because all the waves start simultaneously, all the waves travel equal distances. Directions are different, that's all. Imagine 10 soldiers are very close to each other, standing like this. 10 soldiers are standing like this, people here, 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 like this, in a group like this. They are forming a group. And the commander comes and gives the order, move. Everybody will move like this, like this, like this, right? Everyone will move like this. And if they keep the footsteps like this, exactly what happens? Suppose one person stops in the fourth step, others should also stop in the fourth step, because they keep it in regular intervals of time. There is a high synchronization between them. When the one person stops in the fourth footstep, this one will also stop in the fourth one, this one will also stop in the fourth one, all will stop in the fourth footstep. I say that, so now you will get some words here, all are in phase. What do you mean by in phase? Their condition is same. Phase means condition. In what condition this person is, this soldier is? He has completed the fourth step. In what condition this soldier is? He has also stopped at fourth step. Similarly, so now what is the shape in which these soldiers are spaced? It is a circle. Am I right? All soldiers are in phase and they are in a circle. Now can I call this circle as the point of same phase? Exactly. Because in this circle, if you consider one soldier, ask him where you are now. Sir, I have completed 4 steps, sir. Exactly, I completed it. I am just taking rest now. This will also say that. This soldier will also say the same one, this one, this one. This circle is the circle where all same phase soldiers are present. Similarly, go to the waves now. The waves will form crest and trough and they will move. And if this has stopped in fourth trough, this will also stop in fourth trough, because as soon as this wave has started, this wave also has started in the same time, and this wave also has started in the same time. With what velocity this wave has traveled, this will also travel with the same velocity. Obviously, when the time this reaches here with the fourth trough, this will also reach here by the fourth trough. This distance, this distance, this distance, and all are same. And imagine it in 3 dimensions. A wave traveling here also forming the fourth trough, fourth trough, fourth trough, like this. You will get a sphere. If soldiers travel in all the directions, not only on the ground, but also up, down, below, everywhere, you will get a sphere-like arrangement. And this sphere is called wavefront. This is called wavefront because you have to extend it for each and every wave. A wave here, wave here, wave here, wave here. Now if you touch the surface of that sphere, you will definitely find that each point on the surface of the sphere is the end of the fourth trough. Fourth trough is an example given by me. It may not be fourth trough, but simply to understand, I say that it is the fourth trough. Every point on that sphere, every point on the sphere is the end of the fourth trough of that particular wave which has reached. So if the sphere is like this, from here, if I touch the surface of the sphere, it is the end of the fourth trough. And here it is the end of fourth trough. So shall I call the surface of this sphere as the surface of all the points which are in phase? That means if you just mark a point on the sphere, it is like a football now, or a balloon. Imagine a balloon, a large balloon with a point, small bulb at the center. And if you just touch the surface of the balloon and ask that light, from where did you come? The light says, sir, look into the center, there is a bulb, I have come from that source, sir. You are on the surface now. How much waves you have completed by the time you reached on the surface? It will say, sir, I have completed 4 waves, I am in the fourth trough now. Okay? Ask this wave, sir, I am also in the same condition. I have started from this source. As soon as this started, time of traveling is same, distance is same. All the points on the sphere are in phase. So collection or locus means collection, right? The locus of all the points, that gives the wavefront. This is called primary wavefront. See, you have to add one by one word to your dictionary now. You will have your own dictionary. You will have some few words in your dictionary, and you will have to improve your vocabulary. And you must use these words in the examination. When you talk about wave theory, and you should talk about these words compulsorily. What is a wavefront? Wavefront is the locus of all the points which are in phase. All the points, when they are connected together, you get a sphere. It may not be sphere only. We will see what type of wavefronts you will get. It is the locus of all the points which are in phase. It is a collection of all the points which are in phase. What do you mean by in phase? Phase means condition. What is your phase now? Every human being will have their own phase. PHASC, right? Not FAC. PHASC. What is your phase now? Every human being will have their own phase. The phase of childhood, right? Staying in home, playing, learning from mother, right? Learning to walk, childhood. Going to school, next phase. Finishing the education, next phase. And after completing the education, getting married, having a family, next phase. And job, next phase. And retiring, next phase. Retired life, social service, etc., next phase. And the last phase, finally. Very old, taking rest, and enjoying with grandchildren. That is next phase. So you will have different phase. What do you mean by phase now? It's your condition. In what phase you are now? You are in the phase of education. You are not completed education, not entered into job. You are not in professional life. You are in educational life. Golden phase, that's what we call, right? You are in a very golden phase now, enjoying, no responsibilities, nothing, just to read, and if you want, and if parents put pressure, reading little bit, enjoying the life, and having no responsibilities. That is the best phase of life. So you will get good enough things to eat in your house, nobody will question you. So that is the best phase. So every human being will have their own phase. Can you get people of same phase? Yes. All students, all friends in your class are in same phase. What about your father and mother? Your father and yourself. You have a different phase. Father is in the family life, job phase. You are in the student's phase. And that is a difference. So you collect all these points, they are in same phase, because all of them have traveled equal distances. Suppose this point is in the crest, fifth crest, say, this should be in the fifth crest, because it also has started from the same original source, and it has ended up here. So fifth crest, fifth crest, fifth crest, it should be. That means wavefront is a collection, locus of all the points which are in phase. In phase means same phase. In phase means same phase. Out of phase means different phase or opposite phase. Okay. Okay now? Now, suppose you have a point source of light, bulb, which can send light in all the directions. Then what is the shape of the wavefront? It is the spherical wavefront. Shall I write this as spherical wavefront? So, shall I conclude that a point source of light emits the spherical wavefronts? Definitely. A point source of light emits a spherical wavefront. What do you mean by that? Sir, is this the first wavefront? No. Wavefront can be of any size. Because suppose if I had stopped this light, by the time light has traveled here only, I would have got another sphere here, right? I would have got a different sphere. So wavefront may be of any size, anything. Suppose this wave was given an opportunity to travel only 2 crests, then this will also travel by 2 crests. This will also travel by 2 crests. This one 2 crests, here 2 crests. Everywhere it is 2 crests. So collect all the points which are the second crest. You will get a smaller sphere. That is this wavefront. So then also it is a sphere. It may not be a cylinder. It should be a sphere. So a point source emits spherical wavefront. Now the question is, how does this wavefront grow? Now if you switch on a bulb, just stop it once. You have a wavefront, imaginary sphere around the bulb, which is a collection of light energy, which are in same phase. That surface of the sphere is the point of same phase for all the waves. Okay, that is a sphere. But if you had switched it on continuously, that sphere might have grown, right? Like this, like this, like this. Because that sphere doesn't stop there only. If you continuously switch on the bulb, the sphere grows because all the waves travel. And if you don't give the command to the soldiers that you have to stop, they will keep on moving. What happens to the circle? Circle keeps on growing, growing and growing. That means wavefront grows. Now the question is, how does the wavefront grow? That is the answer, this is the answer given by Huygens. He says that from the primary wavefront, let us assume that this is the primary wavefront now. This is the primary wavefront. First wavefront, say. First wavefront can be anything actually. From the primary wavefront, each point on the wavefront acts like a secondary source. Each point on the wavefront acts like a secondary source, means it acts like its own, or it emits its own light, its own wavefronts. For example, when you see the chalk, you can see the chalk, right? You don't see the sun. But whose light is chalk emitting? Is it its own light? No, never. It receives light from outside, from the sun, and reflects it to you. But that light is originally from the sun. So you must have seen sun in this chalk. No, not possible. Because primary waves come and fall on the chalk. And then chalk emits its own waves. And those waves carry the information of the chalk, not the sun. So whenever light falls on a certain object, secondary waves start from the object. And if you treat that this is a primary wavefront, from the primary wavefront, secondary waves will start. Each point on the primary wavefront will act like a source of secondary waves, and they emit their own waves. So this is the source of light. Say this is the primary wavefront, okay? Say this is the primary, this is the source, and say this is the primary wavefront. It is a sphere. So point source emits a sphere. Now what these points on the surface of the sphere will do, they will emit their own waves. So suppose this, these are the sources. I will take only few cases here. These sources will act like another bulb, say. It is not the actual theory, it doesn't say that it is another bulb. Suppose we take it as another bulb, secondary bulb. They send their own light, and that light makes another sphere. This one makes another sphere. So secondary waves start from the source, secondary waves, and each point on the primary wavefront act like a source of secondary waves, and these secondary waves move forward. And you collect all the points on the edges now. You get a new wavefront, and the new wavefront is here. This is the new wavefront, and if you collect it all like this, it is a new wavefront. So that's how it grows, right? As if you take a plate and give it to your friend. Your friend gives the plate to the other one like this. So once you transfer your plate, your job is over. Then the responsibility will be taken by your friend. Similarly, once the primary wavefront moves out, all points on the primary wavefront emit their own secondary waves, and that grows forward. Here came one question to Huygens. Secondary waves travel in backward direction also. So do you get another secondary wavefront here? No, he said. Secondary waves travel only in the forward direction. Of course, it is just a statement. No proof. Of course, these are the drawbacks of wave theory. There is no explanation why secondary waves don't move back. They won't move only forward direction, right? So only secondary waves move forward and they don't move back. That's why the wavefront grows. Now what about further motion? Again, the points on this will act like secondary waves, and they create their own waves, and they are only in the forward direction. You get the other one. So the sphere keeps on growing, and every point on the new wavefront will act like a source of secondary waves, and these secondary waves are emitted forward and forward and forward. So it is like a relay. Right? You will run 100 meters. You will give the baton to another friend. He runs next 100 meters. So that continues. So secondary waves will carry it forward. Nobody will run back, right? Your friend will not take the baton and complete the negative 100 meters. Then the displacement will be zero. You will not get the prize. So they will move forward. So it grows like this. Now, this is the wavefront. That is his explanation. Of course, we are going to apply this explanation in some of the small derivations in the coming classes. Now, so you may get questions like this. What is the wavefront? It is a locus of all the points, collection of all the points which are in phase. And where do you get secondary wavefront? That is on the primary wavefront. That means all the points on the primary wavefront will act like secondary sources. They emit their own wavefront and the light moves forward. And now, how do you write the rays of light? Sir, if you want to write the rays of light, you have to draw a normal to the sphere. Any line drawn to the normal to the wavefront gives the ray of light. So like this, like this. Any line drawn normal to the surface of the wavefront gives the, normal means it should pass through the center, otherwise it cannot be normal. So that gives the ray of light. So wavefront and ray of light are always normal like this. They are normal. So you can write, suppose this is a point source and it gives wavefront like this, then normal to that will be like this. That is the ray of light. Now, do we have only spherical wavefronts? No. You may have different types of wavefronts also. You take a tube light. Tube light is a linear source, right? It is not a point source, it is a linear source like this. It is a collection of many bulbs kept side by side like this. And you know that a tube light doesn't emit light from this direction. In your house, you just look into a tube light, you will find that no light comes from the edges. It comes only from the cylindrical surface. Light comes from this surface, not from here. No light is emitted from these two ends. So it's a linear source. So if light is emitted only from this side, like this, on all the three dimensions, so will you get a circle like this here? But such things will be done by all the sources here. So you will get a circle like this, and a light travels in all the directions here, and you collect all these points in the same phase. So will you get a cylinder? So type of wavefront emitted by a linear source is a cylindrical wavefront. So a linear source emits a cylindrical wavefront, a point source emits spherical wavefronts, and whether both of them are different, even though they are different, you go to a very large distance. For example, sir, what type of wavefront is emitted by sun? Obviously, it is spherical. But if the sun is at very large distance, since the sun is at very large distance, say this is sun, and earth is here, very small. As these wavefronts grow and grow and grow, and by the time they reach the earth, how do they look like? You are standing just by the side of a very large sphere. Can you identify that it is a sphere? No, it looks like flat. It is a plane wavefront. So, if the wave source is at very large distance, then the wavefront is almost plane, right? Suppose this is a point source of light. Initially, it will emit, spherical wavefront. When you are very close, you can feel that it is a sphere. The waves emitted are sphere, and if you take a part of the sphere, it will look like this. And as it grows, the sphere, the curvature keeps on decreasing, and less curvature. At a certain distance, you will feel that this wavefront is almost plane, right? What about here? Suppose there is a linear source at a very, very, very large distance. The cylindrical wavefront will grow and grow and grow. And if you are standing by the side of a very large cylinder, and if you are looking at the cylindrical wavefront, it looks almost flat. Because the cylinder is so large that you don't see the curvature from either side also. So it looks almost flat. So if it is a point source of light, for a point source, we get a spherical wavefront. Linear source like tube light, it is a cylindrical wavefront. Whether point source or a linear source, point or linear source. At infinity, at a very large distance, it is plane wavefront. It is plane wavefront. So that you must know. It's almost plane, whether it's a cylinder or a sphere, it is almost a plane. Now the thing is, sir, just now we have told that if you have a spherical wavefront, if you draw a normal, it gives a ray of light. Ray of light is our ordinary word, right? That we use it in our ordinary day-to-day life. But wavefront is a special one given by Huygens, Christian Huygens, in his wave theory. You said that for a surface, if you draw a normal, you will get wavefront. Now, a ray of light. Normal to the wavefront gives a ray of light. Now, that ray of light, how is it from a point source? If you come back here. Sir, how are the rays of light coming from a point of source? And if you draw a normal to the wavefront, how it looks like? It is diverging, right? Diverging rays. What about from a cylindrical source? If it is a cylindrical source, so this is a linear, it is a linear source and a cylindrical wavefront, because waves will be cylindrical, they will travel like this and they will form a cylinder like this. Now, what about if you draw a normal to the cylinder like this here, right? They are also diverging. Do you agree? So this is diverging. Because rays of light coming from a tube light are also diverging. From a point source are also diverging. So cylindrical wavefront or spherical wavefront, when the rays are drawn, they are diverging. What about if they are at infinity? Then it is a plane wavefront, and in ordinary language we say it is a parallel rays, right? Parallel rays are the other name for plane wavefront. So if it is a plane wavefront like this, the curvature is so small that by the time you go away from the source, the curvature is so small that it looks almost plane, right? For a best example is, stand on the surface of the earth. Do you feel the curvature anywhere? No. Do you feel that the earth is bent somewhere here like this? You can see it like this, and you can see some countries like Australia and New Zealand at that corner, and by this side another country in the corner. You can't see that. It is not possible. Unless you go to a very great height and see the earth, you can see the curvature. When you are standing on the earth, it is such a large sphere that you feel it almost flat. Similarly, this is almost plane, because you are much away from the point source. Now you draw the rays of light for it. Any normal line drawn to the wavefront gives a rays. So the rays of light are like this, right? How are they? Parallel rays. Usually you confuse this with this one, okay? But plane wavefront, parallel rays. Suppose the question is, what type of wavefront is emitted by a point source of light? It is a spherical wavefront. What type of rays? Diverging rays. What type of wavefront is emitted by a linear source? Cylindrical wavefront. That cylinder keeps on growing. What type of rays? Diverging. Rays different, wavefront is different. What type of wavefront is emitted by a source at infinity? This is from infinity. It is plane wavefront, but it is parallel rays. If wavefront is asked, you have to write plane, not parallel. You usually commit this mistake. What type of wavefront is emitted by a source, maybe linear or point, at a very large distance? You write parallel rays. That is wrong. Parallel rays, they are asking wavefront, so it is plane wavefront. So this is the idea given by Huygens. Huygens says that wavefronts travel in all directions, and they don't require any medium, and each point on the surface of the primary wavefront act like a secondary source, and any normal drawn to the surface of the wavefront gives the rays. So, and such a type of source of light gives such a wavefront. So all these things, ideas were given by Huygens. So Huygens theory became successful when you consider some of the aspects of light like reflection, refraction. Huygens was able to explain reflection, refraction, Snell's law, even diffraction and interference, but he failed to explain properties like photoelectric effect, which is mainly based on quantum nature of light. So nowadays we have such theories also. So regarding, if I continue the theories of light, if I want to say something about this, that I will complete, and then we will go deep into the Huygens wave theory. Now, next, so Huygens was not able to explain clearly how does light travel in vacuum. And for that question, he answered that there is a medium called ether everywhere, and using ether, the light travels, but the presence of ether was disproved later, so that was discarded. That Huygens theory is not applicable everywhere, and it has some limitations. And this idea, why did Huygens theory fail in explaining the propagation of light in vacuum? That part was taken by Maxwell, James Clerk Maxwell. Maxwell said that light is a wave, but it is an electromagnetic wave. You will have a separate chapter for this, but we will have a touch on this one. How does it, what is there in the history, how that science went on changing, concepts went on changing, our understanding on light went on changing its ideas. Electromagnetic wave. Maxwell said that light is an electromagnetic wave. What do you mean by electric magnetic wave? Electric field and magnetic fields combined. Suppose you have a magnet. You know, if there is a magnet, and around the magnet there is a magnetic field. Even if you hold the magnet in vacuum or anywhere, there is a magnetic field. Magnetic field can exist even in a medium as well as in vacuum. So if you can combine electric and magnetic fields, and around a charge you have electric field. So if you can combine them, and you can vary them in a proper fashion in so many number of times per second, then that becomes an electromagnetic wave. You are going to deal with that. So theoretically, Maxwell gave only theory, no practical explanation. Practically it was proved by Heinrich Hertz again. So many names you see, you get. So one by one put forward theory, another started putting it in the practicals, he proved this, so combine, the effect is the theory became successful, and another scientist came and thought of in a different way and used this theory in another manner. So science went on giving many ideas and many new inventions. Now, according to Maxwell, light is a combination of electric and magnetic fields, and these electric and magnetic fields are continuously changing with the time. Timely varying electric and magnetic fields, they don't require any medium, because electric and magnetic fields can exist and vary in vacuum also. So he said that light is a combination of electric field and magnetic field, and all these velocity of light, propagation of light, electric field and magnetic field, all are mutually perpendicular to each other. Suppose this is the velocity of light, then if the electric field is here, magnetic field will be like this. Or if you take this as velocity of light, then electric field here, magnetic field will be like this. They are mutually perpendicular to each other. So speed of light, electric field and magnetic field. And moreover, it is not a fixed electric magnetic field, it keeps on changing. Wave is produced whenever there is a change. Water ripples, water molecules, if they don't vibrate like this, no water ripples are produced. Water ripples can be seen only when the water molecules change their positions every now and then. They should keep on changing the positions. And this is the wave theory. And according to wave theory, light is a combination of electric and magnetic fields. And these electric and magnetic fields are both perpendicular to each other, and they are mutually perpendicular to the propagation of direction also. And he gave a famous equation, that is speed of light is given by 1 by root of mu naught epsilon naught, and you are going to study all these things in detail. This was, and of course Maxwell didn't give only this equation, he gave many equations, and this is one of the famous equation. Velocity of light is given by 1 by root of mu naught epsilon naught, where mu naught is the permeability of the medium, epsilon naught is the permittivity of the medium, they are all the constants. Of course, this is for especially vacuum. Mu naught is the permeability of vacuum, epsilon naught is the permittivity of vacuum. This is the speed of light. And the values of these were substituted and calculated. Velocity of light was got, 3 into 10 to the power 8. The same answer was got, and of course, so that was the theory given by Maxwell. So according to him, also light is a wave. But it is a special electromagnetic wave which doesn't need any material medium. It can even travel in vacuum, but you should have a timely varying electric and magnetic field. And later on, this electromagnetic wave was practically demonstrated by Heinrich Hertz. So Heinrich Hertz proved this, and Maxwell proposed this. And later on we had quantum theory, and it said that light is a packet of energy. We applied it to different case. So in this way, and finally, we had a conclusion that light sometimes behaves like a wave, sometimes like a particle, like a packet of energy. That is called dual nature of light. So in this way, we understand light in different ways, and you have all these things in the syllabus. This is the introduction for wave optics. Of course, that secondary wave concept is important. We will apply the wave theory to refraction in the next class. Till then, keep studying this. With all this knowledge, you enter into the next class. Till then, take care. Thanks for watching. Namaste.